Hello friends, I am Arshi Dhami from Thapar University, Patiala, and I am doing my Masters in Information Security stream. Under my thesis work, I have done malware analysis using machine learning approach under the guidance of Dr. Maninder Singh. Here I am trying to contribute my work contribute my thesis work so that others can refer to it. Here is overview of my thesis. Firstly, I have discussed the various difficulties in analyzing malware. Next, I have briefly discussed the main objectives or goals of my thesis. Nextly, I have described the tools used, the methodology being used, the classifiers which I have used for classification of malwares, and finally the results and important discussions. I have chosen the topic malware analysis because these days the pace development in computer technology is making people more worried about the security of system. More advanced is the technology, more is the risk of getting attacked by malwares. In my thesis review, I would like to discuss that earlier also there are techniques, namely static and dynamic analysis techniques for malware analysis, but these techniques have certain loopholes which limit their use, and I would like to discuss the difficulties in analyzing malwares by these tools. Firstly, the volume of malware is very large and it is really difficult to handle such large volume of malwares. I mean, the database has to be really strong and large. If the malwares are growing at a very high pace, approximately 1200 malwares per day or per hour. Obfuscations. Malware writers often use obfuscation techniques to avoid detection by anti-malwares. Obfuscation is nothing but scrambling of code so that their signatures cannot match with the previously fit signatures in the malware signature set, and they can easily avoid detection. Next is the high number of false positives which are incurred by the use of static and dynamic analysis. Though these techniques can correctly identify malwares, but these have certain loopholes that they can also identify normal binaries as malwares. Detection of virtual environment. Some malwares are so coded that they can detect the presence of virtual environment, and they are being analyzed in a virtual environment. Their working is being recorded. So what they do is they stop their execution, their detection speed. The malwares are so complicated these days that sometimes it requires several minutes to several hours in detection of one particular malware. With this detection speed, it is almost impossible to detect the large volume of malwares. API calls use. Now, what's wrong with API calls use is that there are certain API calls which both malwares and benign files use. So it becomes confusing as to which API calls were called by malware files and which were used by benign files. System degradation. Most of the anti-malwares which are installed on system in one way or other way slow down the system. They affect the performance of the system to a large extent. Overview of thesis. Firstly, our major objective was to capture and analyze the latest malware traffic using static analysis. We have used the dataset which comprises of the most recent malwares 2015 onwards. I have performed static analysis of them, and then I have used sandbox sandboxing technique to perform dynamic analysis. I have used Cuckoo as a sandbox. Then the next objective was to do malware categorization using machine learning approach, and then finally the results were validated and verified with the results of VirusTotal. Next, I would like to discuss the tools and techniques used. I have used Cuckoo Sandbox for the sandboxing. Cuckoo is nothing but an open source malware analysis system which combines the outputs of various malware analysis tools, both static and dynamic, and gives a detailed output of the working file details, section details, registry details, API details, network analysis details of that particular file in various file formats. One peculiar advantage of Cuckoo is that it gives the analysis results in various formats, which may include MongoDB interface, HTML report, JSON format reports, and many others. Nextly, for applying machine learning, I have used Veka. Veka is nothing but a collection of various classifiers and clustering algorithms used in machine learning. It consists of a list of classifiers. Then we need a virtual machine for the installation of Cuckoo or downloading malware so that it cannot affect the normal working of the system. Then I have used Python for coding. TCP-dump is used in the installation of Cuckoo, as TCP-dump is a network analyzer which captures the network traffic and analyzes the traffic on the basis of the host contacted domains, HTTP requests sent, and many other things. Steps or methodology. Our methodology comprises of the 5 steps, namely data acquisition, behavior auditing and report generation, data pre-processing, classification using Veka, and validation of results. Firstly, the dataset used in this thesis or work is of the most recent malwares and has been collected from various online sources, and some of the malwares have been collected from the datasets of various universities on request. Each malware sample is analyzed by Cuckoo and a report is generated. We have used the HTML version of Cuckoo output reports, and the benign malware samples is collected from System32 directory files of clean installation of Windows 8.1. After having the Cuckoo outputs of all the malware in benign files, which sums up to 1230 files, 1230 files, each data pre-processing is done. What is done in that is all the features shown by Cuckoo are input into a CSV file for each particular malware, and then a CSV file of 1230 entries for each malware is obtained. This CSV file is converted into R format, which is a standard file format accepted by Veka. Then various classifiers are applied on this CSV file to choose the classifier bit which gives the maximum accuracy. Then the results given by this classification are verified and validated with the results of VirusTotal. We have used the following classifiers: naive-Bayes, SVM, LMT, Reader, K-nearest neighbor. Results are discussion. Firstly, we have applied Veka on all the features extracted from Cuckoo. This feature list was about 40 features. The results were showing very low TP rate and high FP rate, and the accuracy was very limited, in which, as shown in figure, you can see redder shows the minimum efficiency. Then we selected the best features so as to have maximum accuracy. The features chosen are by random means. We applied first 5 features and then first, second, fifth, sixth, seventh features, and finally we obtained a feature set in which we use the file type, file size, section name, virtual address, entropy, imports, registry keys, and IP addresses. This is our final feature set, which is then applied to Vega, and this time the results are far much better than the previous results. And as we can see, LMT logistic model trees gives the maximum TP rate, true positive rate. Here the classifier is just on the 5 parameters: TP rate, false positive rate, precision, recall, and F measure. And we were also able to capture a list of IP addresses which were involved in the attacks, and by using of whois, we track their locations and we calculate the number of hits, that is by how many times that particular IP has attacked the system. For security reasons, we have hided the private IPs and the public IPs are shown. Some IPs used in the attacks were also in the blacklisted IPs, and on an average there were near about 1 or 2 public IPs involved in the attacks, and the rest were all private IPs. Conclusions. As per our thesis report, LMT classifier gave the best results, and we were able to detect malwares in a timely manner with very less time, and the accuracy achieved was very high, and there was no system degradation. We need not to install any antivirus, as the results of virus totals are also included in Cuckoo report. Future scope. In future, we would like to expand our data set so as to include large number of features and malwares from various categories, and we would like to do the analysis part on the basis of API calls. And to further improve the results of the classifiers, we would attempt to combine the output of one or more 2 classifiers, which is also known as ensemble learning, so that our results can further be improved. This is a list of references I have used for my work, and thank you.